Welcome to Mind XY, your channel for logical thinking and puzzle solving. We are given three equations. The first equation, x squared minus the product of y and z equals 3. The second equation, y squared minus the product of z and x equals 4. The third equation, z squared minus the product of x and y equals 5. All three equations follow the same structure. A variable squared minus the product of the other two variables equals a constant. To take advantage of the symmetry, we multiply each equation by a variable chosen, so the patterns line up perfectly. First, multiply the first equation by y. This gives x squared times y minus y squared times z equals 3 times y. Next, multiply the second equation by z. This gives y squared times z minus z squared times x equals 4 times z. Finally, multiply the third equation by x. This gives z squared times x minus x squared times y equals 5 times x. Now add all three results together. Every nonlinear term cancels out. Nothing complicated survives on the left side. The entire left side becomes 0. The right side becomes 5x plus 3y plus 4z equals 0. This will be called equation A. We now repeat the same technique but rotate the multipliers. Multiply the first original equation by z. This gives x squared times z minus y times z squared equals 3 times z. Multiply the second original equation by x. This gives x times y squared minus x squared times z equals 4 times x. Multiply the third original equation by y. This gives y times z squared minus x times y squared equals 5 times y. Add the three results. Again, all nonlinear terms cancel completely. The new linear equation becomes 4x plus 5y plus 3z equals 0. This will be called equation B. We now have two linear equations. Equation A, 5x plus 3y plus 4z equals 0. Equation B, 4x plus 5y plus 3z equals 0. We use these to find relationships between x, y, and z. Multiply equation A by 3. This produces 15x plus 9y plus 12z equals 0. Multiply equation B by 4. This produces 16x plus 20y plus 12z equals 0. Subtract the first result from the second. The z terms cancel. We obtain x plus 11y equals 0. So x equals negative 11 times y. Multiply equation A by 4. This gives 20x plus 12y plus 16z equals 0. Multiply equation B by 5. This gives 20x plus 25y plus 15z equals 0. Subtract the first result from the second. We obtain 13 times y minus z equals 0. So z equals 13 times y. We now express everything in terms of y. Replace x with negative 11y and replace z with 13y. This gives the square of negative 11y minus y times 13y equals 3. The square of negative 11y is 121y squared. Subtract 13y squared. This leaves 108y squared. So the equation becomes 108y squared equals 3. Divide both sides by 108. This gives y squared equals 1 divided by 36. Taking the square root of both sides gives two possible values. Y equals positive 1 divided by 6, or y equals negative 1 divided by 6. For y equals positive 1/6, x equals negative 11 times 1/6, which is negative 11 over 6. z equals 13 times 1/6, which is 13 over 6. For y equal to negative 1/6, x equals negative 11 times negative 1/6, which becomes positive 11 over 6. Z equals 13 times negative 1/6, which becomes negative 13 over 6. So the system has two solutions. The first solution is x equals negative 11 over 6, y equals positive 1 over 6, and z equals 13 over 6. The second solution is x equals positive 11 over 6, y equals negative 1 over 6, and z equals negative 13 over 6. Both sets satisfy all three original nonlinear equations. The essential idea was that symmetry allows every nonlinear term to cancel out when combined with the right multipliers, reducing the problem to two simple linear relationships. If you enjoyed unraveling this mathematical mystery with us, hit the like button and subscribe for more deep dives into math and science. Let us know in the comments what other puzzles we should explore next. Thanks for watching.